welcome to codeLive. Today, we are going to learn how to implement a GraphQL API from scratch. We will be working with Node.js to create a web server that's going to pretty much have a GraphQL API, and we will be able to perform GraphQL queries against that API. Why we are doing this? We recently announced that now Salesforce has GraphQL support. So you are able to query some of the objects and you have access pretty much to the UI API using GraphQL. But I don't want to cover our GraphQL APIs because next week we will have Mohit Srivastava guiding you through all of those APIs. How can you access Salesforce data using GraphQL? But before getting to that, I want to explain you the fundamentals of GraphQL, the very basics, how a GraphQL server works, how you can define a schema with different types, how can you define the queries, and how can you map those types and queries to server logic. So we are going to do that from scratch today. So we can understand how a GraphQL server works, and then you will be able to play with our GraphQL APIs after Mohit shows you all of the APIs we have available. So if you are a developer that are creating your own applications, maybe you want to deploy your own server to GitHub, or you might want to have the Lightning Web Runtime application that we saw earlier using Node.js with a GraphQL API as well, this will be a codeLive for you. Okay, so let's get started. And I am with my camera again, giving me some issues. I don't know why my camera keeps failing on me. This is not ideal. I just, let me see if it works. No. Okay, don't worry. You don't need to see me. You are going to see the code. Why my camera is freezing, I don't know. It just happened just when I start my life. Yeah, sorry, folks. This is the second time it happened to me. I'm now ashamed. Let me double check the camera. Give me 1 second. I will fix this. Be right back. Now you can see me, right? I needed to cycle my camera so we can have some movement here. I like to move my hands while I'm talking, and that give me focus. Thank you very much for letting me know that I was frozen. It's part of doing things live. Okay, we are back. Before we start with the topic, remember we will have Trailblazer DX in March. You can register now. Go to the developer.salesforce.com website. If you can attend to San Francisco, join us for the Builders Conference, where we will have Salesforce developers, architects, admins, MuleSoft, Slack, Tableau, all of the different technologies available for you so you can build amazing solutions. Before we go into live coding, I can get this presentation started. I want to explain some of the basic concepts around GraphQL. So this is going to be a quick introduction so we understand the fundamentals before we jump into code. If you have any questions, please let me know. Ask in the chat, both YouTube and Twitch, and I will be more than happy to answer live. Okay, so we will have a quick start guide to understand the very basics of GraphQL APIs. But before all of that, what is GraphQL? So, GraphQL is a query manipulation language for APIs. Usually, when we interact with the APIs right now, the most common approach is using REST APIs when we are using HTTP methods to access resources on our server. For example, we will have a specific path or URL to get the users using the HTTP method get. If we wanna store or save an user, we can use the HTTP method post. If we wanna update the user, we can use the HTTP method put or patch sometimes. If we wanna delete an user, we will use the HTTP method delete. Normally, when we are using these REST APIs, when we are getting and reading information, if we want to just filter out the fields that we want to get on the result, normally that result is a JSON object. If we want to filter those fields, we will need to implement a lot of logic just to give us the specific fields we want. So GraphQL tried to solve that issue of just creating some sort of like a query language to ask for information and just the fields that I specifically need with just one API endpoint. So a GraphQL server is just giving me a single API endpoint, and by using a GraphQL query language, like the specific specification they define, I can ask for information. And I can also insert information or update information into my server. All of those queries and types can be defined by a schema. We will see what our schema looks like. You can see something on my image here on the slide. This is a schema for our application I built before for managing properties on a rental company, like some sort of an Airbnb or a company that can rent properties as well. GraphQL is an alternative to REST APIs, and it's very common right now, very useful for mobile applications, and it's getting a lot of the market also in front-end applications. Most of the front-end applications are starting to implement GraphQL clients to consume these APIs. It was developed by Facebook in 2012, and it was released to the public in 2015 as an open source specification. There is the GraphQL Foundation. You can go to the website graphql.org, where you can read the spec, the whole documentation around all of the different things that you can do with it. Today, we are just going to cover the basics. GraphQL is an extensive subject. If you like this, we can cover more of the other topics like subscriptions. We can let you have like real-time information from a GraphQL server, or the relay specification to be able to have pagination, all those things. If you like the content that you are seeing today, let us know on the comments in the chat so we can continue creating content for you. Well, here we are speaking, responding to Luis. You are asking me about fields or filter records. Right now, we don't care about the data that we are returning. And I am going to keep the example without using Salesforce data. It's going to be any source, and that's one of the interesting parts. So you can have any data source behind a GraphQL server. It could be a PostgreSQL database. It could be just a single JSON file. It could be multiple databases or multiple services integrated into one. It could be a Salesforce API. No, it could be anything else. The implementation or the logic is going to be added by you. GraphQL doesn't specify a backend. It doesn't specify a data source. You provide the data source. GraphQL only specifies a way to define the schema and the types, and a way to query and mutate those types. And this is what we are going to cover. And then on the live example, I'm going to show you how can we define the schema, the different types, relationship between the types. So we are going to do some data modeling. Then we will implement the logic behind, and now we will start getting the idea. Pretty much the GraphQL APIs that we have at Salesforce were implemented in similar way. We are not using Node.js. We are using Java in Salesforce, so it's different libraries, but it is the same concept. We have a schema, and the schema maps to actions on the server. Okay, cool. Let's continue. Let's talk about the schema and types. So the schema is the file or the definition of all of the different types that I have on my application. I can have on the schema the object types. I can have the queries and the mutations. Each of one of those types can have properties. So we have scalar types, and we can define our own object types that can be more complex. For the scalar types, we have integer, which is a signed 32-bit integer. We have floats, strings, which is an UTF-8 representation of a string. We have booleans, and we have a special scalar type, which is the ID, that it is used to represent unique identifiers. This is going to map to a string. You can also define your custom scalars, like the custom types for your properties. Some of those examples that you can find on the like different package ecosystems are, for example, date or JSON, or you can define your own. These are not part of the specification. These are types that other people can define and distribute on the different package ecosystems. For example, in Node.js, there are people that have defined a specific scalar type for a date or for a JSON object. How can we create those object types? So here we can see an example of the code we are going to write later of 3 different types. We have a property, we have an address, and we have a feature. So let's imagine that we are creating an application to sell properties. We are going to sell houses, for example. So my property has an ID and has a description. I have a text that describes the property in specific words. Then I have an address. Since an address is a complex object, I am creating a specific address type that contains the street, the city, the state, and the zip code. The property can also have features. For example, if it has a pool, if it has air conditioning, the number of bedrooms, number of bathrooms, all of those different features, I am creating an array or a collection of features, and I am defining a specific type called feature that has a type and a description. So from here we can see how can we define those object types. Let's focus on the property. If you see the ID, we have an admiration symbol that means that that property is required. So when I am querying the property or when I'm mutating the property, like performing an operation with that property, that ID needs to be present. But the features can be null. I don't need to specify the features list because I am not specifying that admiration character. The same to the availability. If the property is available or not, I am not defining that this is required. All of the types for, all of the fields for address are required, and for the feature, just the name. And I can have relationship between different types. So here a property has a relation to address and has like a multiple relation to features and so on. So all of my different types can be related. There is also another special type, which is the enum. So I can have like a enum that defines multiple values. I am not using that on the example, but it is some other type that can be used in GraphQL. No questions, I will continue. So this is how I can start modeling my data using GraphQL. Then let's talk about the operations over that data, like the queries and the mutations that I can perform. So queries are the read-only operations, like the operations that are going to allow me fetch information. And the mutations are the operations that allow me to mutate data. That means insert, update, or delete. So all of the operations that changes data or mutates data are going to be under mutations, and all of the operations that reads data are going to be under queries. For example, my application has two queries. Available properties, it is a query that returns all of the available properties. So the name of the query is called available properties, and it returns an array of properties. If you see those two admiration signs, that means that the array needs to be present, even though if it is empty, it needs to be present, and all of the elements of that array needs to be a property. It cannot have null values. You can also define filters to a specific query. For example, properties by city. You can pass the city as a string, and it will return a list of properties. And you can have multiple arguments as well. If you want to define like a specific, more complex query, that can be done here. But as you can see, we are just defining the shape, like the contract of the query. We are not defining the implementation. And here we have the mutations. So the mutations, remember, are those that can let me update, create, or delete data. We have three different operations here. Create a property. It will receive a property input, and here we have a different type, a special type that is going to be only used for mutations, which is the input type. So here, to create a property, I am adding a property input, and it will return the property that it has been created. I have an update property mutation that needs the ID of the property I want to update and the specific property input with the fields I'm going to be updating for that property. And I will return the updated property. And I have another mutation to add a feature to a property. So remember that features are a list here. Features are a list in my property type. So I have a query to add features to that property type. It will require the ID of the property and the feature information that I'm going to be adding. So I create three different inputs for those mutations, and all of those mutations are going to return properties. So I'm just only defining the shapes of the operations and the types that my application can perform, but I don't have any logic. And having this shape is great because any other client that is going to consume my application knows what it is available for them. One of the great things about GraphQL is something called introspection. What a difficult word. So introspection allows you to pretty much read the whole schema and returns its documentation to you. So people that is consuming that API will have access to all the queries, all the different types to facilitate the work. And we will see introspection in like working while we implement our example. How can we map all of those operations like the queries and the mutations to real server logic? So we are going to implement a server that is going to perform these operations. How can we map just the definition to the logic by using resolvers. So a resolver, the name says it, resolves a field or resolves a query or a specific property from that schema and returns a value. So how that works? Let me show you the architecture here. So we have a client. Normally that client is the front end of an application or the mobile client or any other client that is consuming data on a GraphQL API. And we have the schema. The schema lives on a server. So the server is the one that has the schema. The schema is going to be executable. And to make a schema executable, it needs to have the combination of both the schema definition or the type definitions and the resolvers. So remember that we have two types of operations, the queries and the mutations. And those queries and mutations are going to map into resolvers. And the resolvers are going to be functions or logic in your server. Depending on the language of your choice, the resolvers can be anything. In my example today, I'm going to be using Node.js, but if you are implementing a GraphQL server in Java, for example, the schema, the type definitions, and the mutations are going to be the same thing. The only thing that changes is the resolvers, like the functions that these operations are going to be mapped to. So this could be a class and a method. This could be a JavaScript function, a Python function, etc. And the data that is coming to provide these resolvers can come from anywhere. GraphQL doesn't specify the data source. It doesn't tell you, you need to use PostgreSQL for your data, or you need to use MySQL or whatever. No, you are bringing that data and connecting that data. So GraphQL gives us a very good way to communicate between a client and data on a server. In JavaScript, which is the thing that we are going to be working today, how a resolver looks like. So I have an object that maps the queries to the specific queries by name, so available properties or properties by city, and that is just in a synchronous method in JavaScript. And each of those methods receives 4 specific arguments that are very important. Normally, the first argument is ignore. It represents the previous object. It's used when you have a nested object. For example, if you are going to resolve a nested object and you need to access the parent object or the previous object. But for queries, it is not used. The important one is the second, arguments. Those are going to be the input parameters of the query. Remember the properties by city. This city, it's coming in the arguments object. Context is a special object that is shared across all of the executions. And it can have like very special contextual information. For example, the authorization object, the logged in user, the permissions that user has to perform operations. But this is something that you implement, or certain GraphQL frameworks gives you that contextual information. And info is more advanced object that is used for introspection purposes. It will give you now the full representation of the query, and some other libraries uses that object to perform operations. But normally, we will use the arguments and the context. And the same applies for the mutation. So as you can see, all of the different mutations are going to be under that mutation property, and it has the same 4 arguments. Object, the arguments that contain the input parameters of that specific mutation, the context, and the information. And we will always need to return. I am not adding the code in there because of obviously for space purposes, but we are going to implement that. And you will need to return an object that has the shape of the return object that you are specifying. If for some reason you are trying to return a different type or a different shape, or calling the query with a different input, GraphQL will perform automatic validation for you and will return an error. So we already have a contract specified, and GraphQL is going to perform those validations for us. Perfect. If anybody have any question, please let me know before I start building this example. So it is live coding time, my most favorite thing. Okay. So I shared this website, which is the graphql.org, the website of the GraphQL Foundation. Here you can get the information of the GraphQL specification, learn more about the GraphQL, see some examples. This is the way or the best learning resource. And for today, I'm going to be using Fastify. Fastify is a web framework for Node.js. I have used it before on codeLive. Is my favorite framework. Normally, the standard or de facto framework for Node.js is Express. If you have built web server applications with Express, you will pretty much understand what I'm doing with Fastify. It is not that different. But if you want to build a new project with Node.js and you are an Express user, I would definitely recommend you to use Fastify. If you want to implement the GraphQL server either with Express or with Java or with any other programming language, the concept is going to be the same. I have a schema, and the schema maps to resolvers. So I'm going to be showing you how to do that with Node, with the specific libraries I'm going to be showing you today, so you can understand how to connect those two worlds together. And the library that we will use for GraphQL, that it's compatible with Fastify, it's called Mercurius, as the Roman god. Mercurius, yes. So we will use Mercurius. It is a plugin for Fastify that allows you to have GraphQL support. So let's get started. So here I have a folder. I'm going to create a new Node.js project. Let's call it GraphQL from scratch. This GraphQL from scratch project will be, let's try to build that properties API using the schema I showed you in the presentation. But let's do a hello world first, because with the hello world we can understand how things works and see if everything is working for us. So I have an empty folder. The best way to start a Node.js project is executing npm init with the JS parameter. It will create a package JSON with the main information so I can start working. And let's install Fastify, Mercurius, and GraphQL. So we are using those three dependencies to build our application. Fastify is going to be the web server, the one that provides the API. Mercurius is the one that provides all of the GraphQL compatibility with Fastify. And GraphQL is the official library for GraphQL that is going to take care of compiling the schema, performing the data validation, etc. And let's open Visual Studio Code and create a new server. So let's create a new server file, and let's update a couple of things here. On my package JSON, I want to specify two scripts. So let's wait while it activates extensions. It takes some time. Okay. When it finishes, I'm going to start working. It seems it's taking a lot of time activating extensions or what? Give me a second, because I have a lot of different extensions to work with. Okay, now I can work. Oh, look at this. What a mess. Okay. So I am going to create a script to start my server in production mode. And I'm going to create a script to create a server in development mode. This watch flag allows me to refresh the server after I made any changes. So it is monitoring the changes on the JavaScript file, and it is automatically restarting. This is a new feature of Node.js 18. And I want to use module for the type of modules on my application. Instead of using require, I am going to use ESM modules, which allows me to have the import and exports. So now I have the server. Let me import fastify from fastify and import Mercurius from Mercurius. I'm importing those two dependencies. How the zoom is looking. Let me see if you need more zoom. If you need more zoom, let me know. So I'm importing those two different dependencies, and then I will create an instance of fastify. So let's create an instance of fastify. And let's specify a logger, because I want to have a logger or logging information. And after specifying the instance, I'm going to register a plugin. So I'm registering Mercurius. And Mercurius requires the schema and the resolvers. So let's define a schema and let's define resolvers. And since this is going to be a server, we will need a route, an API route, to test the query. Let's do a get API route. Let's call it test. This is asynchronous request reply. And then define a query. And I'm going to reply running that GraphQL query. So this GraphQL method here in the reply, it's a decorated method that Mercurius is adding. So after I registered the plugin, now this GraphQL method is available, so I can run queries on my server. Last but not least, I will create a start function to listen. So pretty much I will have a try catch here, because if the server fails, I will need to have information about it. If it fails, I'm going to be using the logger to log the error. And I'm going to exit the process with exit code 1. Normally on Unix operating systems like macOS or Linux, when you exit a process with 0, that means the process was successful. If you exit a process with a different number, it means it was unsuccessful, that an error happened. So this is just to signal in other applications that might be using my server. And here I just need to listen fastify on a specific port. Let's say the 3030. Okay, fastify is listening on 3030. And if there is any error, it will log the error and it will exit. The last thing we need to do is specify our schema. So let's create a basic schema here. Our schema, we will have a query, and that query, let's call it say hello, and it will return a string, right? Say hello and return a string. And the resolver on the query object has a method. It will be asynchronous that return hello codeLive. So what I have here, I have the schema, I'm defining a query, and the query is being resolved. So when I execute this query from a client, I am executing say hello, and this is returning this value. Okay? So the last thing I need to do is execute that query. So to execute that query, let's run query, say hello, and let's get the value. Let's see if this works. Okay, I'm executing say hello and see what happens. And I don't think I need this. Maybe. Let's give it a try. So let's run the server. npm run dev. If there is any error, it will let me know. If everything works, nothing happens. Oh, I am failing on something, and it is that I am not running a start. Obviously, I need to execute the start function, otherwise this is not going to work. And I need to save. Okay, perfect. Now I have an error. This is beautiful. Fastify is not defined. I'm thinking on a party. It's fastify, and now it is working. Thank you for the ones that maybe catch that error in the chat. Okay, now the server is working, is listening on the port 3030. I'm opening that port 3030. I don't have any slash route, but I have a test route. And the test route is telling me that I have a validation error. Expected name found. I have a GraphQL validation error because I'm trying to perform a query that is not running. Maybe I just need to execute say hello, and that's it. Or just without. Okay, cool. Yeah, I was specifying a named query without the specific query. Okay, so here I am now passing the query that I want to execute, which is say hello. This is running the say hello function and is returning the data, which is hello codeLive. We can have this a little bit more complex by specifying a type. So let's specify a type. Let's specify a type called hello. This type has a name, which is a string that is required, and a message, which is a string. And say hello now will require a name and a message. And it will return hello. So here I am changing the query. Now I am getting two parameters, two arguments, name and message, and I'm returning an object called hello. So the resolver obviously changed. I don't need to check for the object. I just need the arguments, and I'm not using the context. So let's extract the name and the message from the arguments. So I'm getting the name and the message from the arguments, and I'm returning something like this. Let's say this is some sort of a chat. So name, it is saying a message. So now I am executing it differently. If I don't specify the parameters, this is going to show me an error because I have a validation error. I'm expecting the query to have those two parameters. So I need to specify the name. Here it's going to be, let me get a name from the chat. Let's get Akshay, okay. And the message, learning GraphQL. But this will return a type. So now this will return a type, which is a message. Oh no, I'm having an error in the resolver. The resolver needs to return a message, a hello object. So the hello object has a name and it has a message. So obviously I need to return the specific shape, otherwise it's going to fail. And I can get those properties. Give me the message, give me the name, sorry, and give me the message. So I'm querying from the hello object that this is returning the name and the message. If I run this, I am getting the name of the message. And if I just only ask for the name, sorry, for the message, I am just getting the message. So this is how I specify the query. If I just ask for the name, this will only return the name. Or I can return the two properties, name and message. If I have more fields, I will be able to perform a better filtering here. So this is how I was able to define a schema and map that schema with a resolver. But I am seeing a problem here. First, testing this is not the best way by writing those queries with this route. So I'm going to get rid of this. I don't need this route. And the basic route is going to perform a redirection to a special route called GraphQL. And I will specify a specific property here called GraphQL. So GraphQL is an UI interface to perform GraphQL queries on a more friendly manner. So if I go to GraphQL, now we can see this browser here. As you can see, this is way better to perform those operations. On the left, I will run the queries, and on the right, I will get the result. This button here is the Documentation Explorer. Remember that super complex word that I wasn't able to say at the first time, introspection? Now it flows. Introspection. So GraphQL uses introspection to generate documentation. So if I click on documentation, I know that I have a query called say hello that has two input parameters, name and message, that returns an object called hello that has two output parameters, name and message. So I can easily perform the query. say hello, and it will give auto completion. The name, it will be Luis F. And the message is going to be, I like GraphQL. And the output parameters, I'm getting name and I'm getting message. So as you can see, GraphQL is validating the queries. If I am writing the query wrong, it is showing me messages. It is auto-completing the fields I can query thanks to that introspection. And when I run this, I am getting the data from the server. So the best way to test APIs where you are building APIs is by using GraphQL. GraphQL is also a standalone project. So there is a desktop application that you can install and you can connect to any GraphQL API, and it will allow you to have this type of interaction. If you take a look at the introducing the Salesforce GraphQL API, I think it is the second part, not the first part. There is a second part of this blog post. I show you how can you use GraphQL. Let me search that. GraphQL API on the blog. We will share these resources with you after it, but if you are curious, you can take a look. And there I show you how to configure GraphQL to connect to the GraphQL Salesforce APIs. Okay, but let's not derail. Let's get this a little bit more production ready, because I'm having another thing that I don't like, which is, what if I have a complex schema and this grows and I have a lot of resolvers? I'm keeping everything under one specific file. Let's have separation of concerns and work better. So I'm going to create a GraphQL folder. That GraphQL folder is going to contain the schema in GraphQL, is going to contain a resolvers.js file. So that way, I can also create a schema.js, which is going to load and compile that schema.jql file. And let's implement this in JavaScript so we can separate the concerns here. I like where we are going. So now let's specify a little bit more complex schema. So let's reuse the property type with the description and the address. Just keep it simple and available. Boolean. And let's have the address that has the city. No, it has the street, the city, the state, and the zip code. This could be a number. So I have property with an address. Those are going to be my types. And let's define a query. Available properties. And it will return a list of properties. So now we have a more complex schema. A schema that return available properties, and we have a property object that has a description, an address, and a Boolean that says if it is available or not. Awesome. So now let's implement the schema. This pretty much is going to load this file and return this file as a string. So let's import read file sync from Node.js, the FS module that allows me to perform file system operations. And let's export this schema, which is pretty much read file sync. And let me load that file. Let's have a new URL specifying the schema.gql, and the reference or the basic, it's import meta URL, and this needs to be UTF-8. Okay, let me format this, and I will explain you. I don't have any formatter. Okay, this is not a problem. I can do this. Cool. What I'm doing here is I am reading the file synchronously, and I'm returning or exporting this file as a string. So this is what I'm reading it using the UTF-8. And this here is a little trick to specify the route of the file independently where I am. So this is relative to that folder where the schema file lives, the GraphQL. Cool. So now I can replace in the server this schema object. Bye-bye. And I will import that schema object from GraphQL schema.js. So I'm getting it from schema.js. Obviously, I'm having an error because I don't have the resolvers for that specific schema. So this will fail. Now let's implement the resolvers. So export const resolvers equals, and I have an object. So I have a query, available properties. This is an asynchronous method that has some arguments that we are not using. And let's say that it returns an empty object. So far, I'm returning an empty object. And let's import that resolver here in the server the same way. Import resolve. It is resolver or resolvers. Resolvers from GraphQL resolvers.js, and delete this object that I created here. Okay, now I am loading both schema and resolvers, and I have an issue here. Unexpected token. Okay, I am lacking an arrow function here, and now this works. So now I was able to implement the resolver in one file and the schema in other file. So this is going to be more organized. Now the server.js just focus on server operations. I don't have any GraphQL logic here, and I will be able to get properties. But our resolver doesn't have any logic. It's just returning an empty array. Let's change that. So we can have a list of properties. It is going to be an array. And the properties, remember, that have a description, a big house, and it has an address. The street of that address is 123 Elm Street. City is going to be Miami. State is going to be Florida. And the zip code is going to be a number, 33661. That's a zip code in Florida, I guess. And this property is available, right? And then let's create another property that is not available. False. And this is 321 Evergreen Lane, Springfield, Missouri, I guess, and another zip code. And this is a big pink house with yellow people. This is the Simpsons house, I guess. So now I have two properties, one available, one not available, and I need to implement the logic. So what I'm returning here is the properties, and I'm using JavaScript to perform a filter operation when the properties are available. Available. Just return the properties that are available. That's it. This could be a database operation. This could be a REST API call. This could be a JSForce call operation to a Salesforce API. This could be a filtering through a CSV file. The data source is defined by you. GraphQL, as I mentioned initially, doesn't care about how you implement the data source. It only cares about the shape of the objects that you are returning. So available, otherwise it's going to fail. Available, thank you. So it only cares about the shape of the object that you are returning and the shape of the queries. And then it stitches together the schema and the resolvers. Okay. Don't worry. My camera froze again? Nice. We don't need a camera. Thank you. This is great. Well, let's check if this works. Go to GraphQL. Refresh. Now say hello doesn't exist. So this is why it's failing. Let's delete. Check the documentation explorer. Now the query is telling me that we have available properties and that it returns a property with description, address, and availability. Let's run that query. Available properties, but I just only need the description. When I run this, it's giving me a big house. I don't need the address. I don't need the available type. I just need the description of the house. And I'm just asking for that. If I want the address, I need to specify specifically what things from that address. Since this is a nested object, I will need to say, okay, give me the city of that specific property. And I'm returning the city where that house lives, which is Miami. Now I can ask for the state and the zip code and the street, and it will give me all of the information. So this is the query language that I'm specifying here. We can change this a little bit in these 2 minutes. Let's have these 2 properties as available. And let's change the schema to have these available properties by city. So let's specify a city name. Cool. So I'm having this city name. So I can show you the arguments. So on the implementation, I am getting the city from the arguments, and the filter is not going to filter by availability, it's going to filter where the city is equals the city that I am passing. So I'm just changing the logic. Let's say I just want these available properties to give me a property by a specific city. And when I run this will fail because now my query is expecting an input type. My query is expecting, if I refresh the introspection, my query is expecting a city. So I need to specify the city here. Give me something in Miami. It will return anything. I am doing something wrong here. Oh, because the city is in address, not on the property. Now this is going to work. Okay, now I am filtering the properties from Miami. And if I am looking from Springfield, it will give me the properties from Springfield. If I pass a different city, Bangalore, I am not having any property in Bangalore, so this is why I'm returning an empty array. Okay, so we are out of time. This is pretty much how you can implement a GraphQL server from scratch. So remember, the main message here is that you need to have a schema. That schema needs to be mapped to resolvers, and the resolvers are the ones that are giving you the logic. Those are the ones that pretty much are stitching together the schema definition and the operations that you want to perform. And I'm using a server or an API framework, in this case, Fastify, to serve that schema so any client can consume it. Before I go, I will invite you to take a look at the GraphQL API documentation that we have. Wait for it. I don't want to go too deep into this. Mohit Srivastava is going to show you all of those available APIs next week on codeLive, so don't miss it. Go to the developer website, check for all the different GraphQL resources that we have published. This is the Exploring the Salesforce GraphQL API Part 2 blog post that I was mentioning before, where I show you how to configure GraphQL with the Salesforce API so you can perform different operations. And we also have GraphQL support on our Postman collection. So if you go to Postman on the Salesforce Platform APIs workspace, you can take a look at our GraphQL examples. For example, you can get an account by ID using a query. Here, this is a GraphQL query where I am getting the account object, specifying an ID. Or I can get contacts, or the contacts with a specific account, and you can see some other examples here. But this is something that Mo is going to cover next week. Let's see if this works. Awesome. So thank you very much for joining me today on this codeLive. I hope you like it. Please let us know if you want to continue seeing GraphQL content. I can talk to you about like more advanced topics. For example, on the example that we have here, we are getting some edges, nodes, and some other things that are a little bit more different than what I show you today. This is the relay specification that is very useful for pagination. We can talk about how this works, how can we query this type of information. We can talk about best practices in production. We can talk about security. Let us know. We can create a bunch of different content for you all. Also, a new season of codeLive is going to start pretty soon. Let us know what topics do you want us to cover so we can start creating that content for you. See you on the next one, and bye-bye.